Hello, this is Arjang. Today I'm going to talk about the chapter 5 and example 14. We are going to construct this model with the STAAD Pro and compare the results with analytical solution that is presented in your book. So in order to start, let's hit new project, select plane, call it chapter 5 example 14. Then we have to specify the directory. Let's select chapter 5. Okay, the unit system is US customary. Fine, we can continue. Next, we have add beam, finish. Let's make it front view, our grid. Close the grid, specify the coordinate system for our points. We have A, B, C, D, E. A is 0, 0. B is 6, 0. C is 12, 0. D is 18, 0. E is 24, 0. Then we have to select these add beams, then connect the nodes together. You see, it updates it and it gives you the beam number also. The next step is that we have to define the properties for this problem. This problem is a little unique. So if I make the labels, node numbers, so for the members between 2 and 4, we have 2i. The moment of inertia is 2i. And for between DE, for 3, 4, and 5, and 1 and 2 is I. So in order to do that, first let's define a property. So in General tab, go to the material. Let's create a new material. Let's call it, but the point is that the unit system is not matching the given problem. So let's close it. Go to the input unit system, make it inch, close it, okay. Let's create it, create new material. The modulus of elasticity is 5,000 and close it. Now we can specify two different sections. The one which is called I, let's create it, define. Let's call it rectangle, or we can find an equivalent rectangle, so it's good. We can make it new. The I is 8,000, so it's going to be 96 the width, and the height is 10. So the resultant is going to be 1 over 12, 96 h cube. So it's going to be 8,000. Let's add it. The next one, we need it to double is 2i. So this 96 is going to be 96 times 2 is going to be 192. 192, then add, close. So this 2i is going to be assigned to the middle members, and the first one is going to be assigned to the first and the end member. After defining the cross sections, we have to go to the support tab, create, make it pin, add, create, make it roller, release fx, fz, mx, my, mz, add. Then we have to assign this support to node number 2 and roller to node number 4. Did that. The next step is that we have to go to the load definition. Let's change back the units to feet. Okay. Go to the load and definition. Go load case details, add a load case detail. Load case number 1 is fine. Add, close. Under load case number 1, we have to define 2 loads. We have a nodal load of 30 kips downward. Let's add it. Then also we have a 10 kip feet moment. MZ 10 kip feet. It is counterclockwise, so it's positive. Add, close. We have to assign the 30 kip to the node number 1. And also the 3 kip feet to this node, number 5. The scale is a little big, so I have to go scale, apply immediately, make the point force the scale a little bigger to make it smaller, and also point moment, let's make it also bigger. Okay, if you want to see the values, you should right click, labels, U values, load values. Okay, we see that, correct, everything is fine. The next step is that we have to define a load analysis type. We are going to go to analysis and print, add a new analysis, close, go to analyze, run analysis, save, done. We are good to see the results post-processing. Okay. The green is the deflected shape. Go to the scales, apply immediately, make the deflected shape displacement bigger. Okay. Now let's compare the results to the analytical solution. So if you see it on the right hand side, right top, we see the table in the table format. We can change display unit. We can go to the dimension, force unit, make a rotation 5, and section unit, the structure unit, make the displacement also 4 or 5. Okay, so it's a very accurate results. We can see that. Let me go to the structure unit again. The radian, we should make it 5. Okay. Now let's, for instance, compare the displacement for node number A. For node number A, we have a minus 0.18 inch displacement, which is exactly like your hand calculation. We can compare all of the results here. Then the next step is that we can see the reactions. We can see the bending moment diagram. We can see the shear force diagram. We can see the shear force diagram. If you want to see the values, you should go to views, results, view values, beam results, bending, shear, and also node, global Y, annotate, close. So you see that. If you want to see the beam, you will see that, and also displacement. If you want to see the values for displacement, also you can see it. Go to results, view values, nodes, global Y, annotate, close. So you see the displacement, and it's very close to the hand calculation. So we did with both methods correctly. Thank you so much. See you in the next one. Bye.